All right, team. We taught short prompts at ChatGPT 5, and it kept handing us full working apps in one file. The cool part isn't the visuals, it's how the model decided what to build, the little rules, the little loops, the clean UI. Let's walk through what we made together and call out what GTP5 is doing behind the scenes. So, for this canvas city grid, this first one, we asked for a tiny city, roads, lights, cars, and walkers. And what GTP5 did is it picked a simple grid, set a timer for traffic lights, gave cars the follow lane, don't overlap rules, even though some of them keep bumping into each other, and it stashed neighbors in buckets, so speed will stay smooth. It even dropped in sliders and live stats without us spelling all that out. So the takeaway is the model doesn't just code, it chooses safe defaults and a loop that stays ready at 60 frames per second. Now for the ant colony, we asked for ant stat explore, find food, and learn paths. Under the hood, GTP5 set a tourist world, wrap edges, 2 pheromone fields, 2 food and 2 nest, and a ping pong update so trails fade and diffuse. Ants sample left, forward, and right, and steer to the highest scent. No fancy AI, just small rules that emerge in the past. Now why this matters is it plans state up front, like in arrays, steady DTs, and cheap math, so the swarm just keeps scaling. Now for the hex hive or the beehive, we asked for a hex grid where bees forage and fill cells with honey. Under the hood, it chooses the axial hex math for clean coordinates, gave bees a single state machine, forage, return, and deposit, and rendered honey as per cell fill levels with tiny glow. Now why that matters is GTP5 maps words to data like cell, trail, deposit, then wires the updates and the drawing and the UI around those nouns. So for the water ripples, we wanted raindrops making rings that add together. So under the hood, the model used a pool of rings or reuse objects, linear radius growth, and alpha that fades on its own curve. The draw order is the newest first, so edges stay crisp. Blend mode is lighter, so the overlaps feel watery. The results are kind of like a smooth, cheap, and no GPU tricks, just, smart ordering. So for snowfall, we asked for cozy parallax snow and wind and twinkle. Under the hood, GTP5 spits flakes into layers. We used a tiny off-screen sprite and tied drift to wind and times that by layer depth. It uses a single frame loop, and then when paused, it stops working. So the lesson is it balances pretty and fast by caching once and reusing everywhere. Okay, then we have this SIR graph, which is basically like a contact network for like an epidemic spread. It's a 4-slide layout for the graph, gets you your list, runs the SIR updates in 2 phases to avoid bias, infection and recovery, classic small DT formula, and mini chart trails. And it matters because GTP5 turns a math model into a tool, sliders, hover readouts, and clean reset. Next, we have something pretty cool. It's the warehouse robots, and that's this schematic is from the MAPF as well. So we asked for robots that plan around shelves and don't crash. Under the hood, it generated a grid layout, ran A for paths, then booked each move in a timetable so bots can't head on or swap. If a conflict pops up, it inserts a wait and replan later under a budget so frames don't hitch. The big idea is the model mixes planning plus fair scheduling so lots of bots can feel calm and not chaotic. As you can see, they don't really generally bump into each other. They wait in line and they can go at a very rapid pace. And this is pretty much what Amazon uses. So then we have next a heat fill with a 5-point stencil. We wanted a 2D heat diffusion so you can paint on it. Under the hood, it used 2 float 32 buffers and a classic 5-point update. It checks stability each step and auto clamps DT if we crank the sliders too far. Legend and stats update off the quick pass, so no heavy scans or anything like that. GPT-5 adds guardrails so we don't melt the sim. Now we have the L System Studio next. We asked for a tiny plant grammar that grows and exports SVG. Under the hood, it pre-computes each iteration, no stalls, animates growth by revealing segments, and outputs an SVG with proper view box and stroke widths. So why that's going to matter is it treats export like part of the build, not an afterthought. Okay, next we asked for the maze racer. We asked for maze generators and live race. Under the hood, 1C drives everything for fairness. Solvers tick in lockstep per frame, and each logs expanded nodes, path length, and time. The takeaway is GTP5 can stage an experiment, not just draw a maze. Next, we have the sorting arena, multi-algorithm. We asked for a side-by-side sort showdown. Under the hood, each algorithm is a step generator that yields after tiny work, so the UI stays snappy. A shared seed builds identical arrays. States track comparisons and writes across cards. And so why that's going to matter is that the model picks a fair scheduling pattern without us asking. Okay, so the Video Pixel FX Lab side by side. We wanted upload, original versus process preview with real effects. Under the hood, it decodes once to a staging buffer, runs per pixel math, grayscale, hue, sobble, and blur on a downscaled canvas, and then paints both panes. Safeguards prevent zero size errors, fit toggles contain versus cover. So the result is responsive processing and no CSS filters, just real pixels. So in this series of editors, we have the video BCS processor uploader and frame tools. So we asked for brightness, contrast, and saturation, just a little bit of something on a single canvas plus snapshot. Under the hood, GTP5 keeps an off-screen processing scale for speed, updates only when the video time or sliders change, and file names and snapshot with timestamp. So to avoid wasted work, the point of all this is it can avoid wasted work and still look sharp on high DPI. Okay, and for the Tiny Image Lab, Before and after editor, we wanted an image pipeline with a draggable split bar and a PNG export. Under the hood, we have one pass-through pixels, ordered filters, and a separated blur so big radii don't kill frames. The split is just clipping at X, cheap but clean. So, simple math, well ordered, and it feels pro. It really does. So for the CPU ray tracer, we asked for a reflective sphere with a tweakable material. Under the hood, the ray sphere hits, a sky probe, and roughness and metal sliders tied to simple shading. It keeps the CPU friendly and still sells the effect. Now why this matters is GPT-5 can sketch complex ideas with small math first. Now the neon racer, we asked for a neon track, boosts, and bumps. Under the hood, it used a straight runner track, collision as box hits, and speed boosts as quick multipliers. Camera sway and color help sell the vibe without 3D engines, and the takeaway is the model just picks, just enough to feel fast or to feel like things are moving. So for the neon synth wave and grid and wireframe mountains, we wanted that retro grid and horizon. So under the hood, it draws a perspective grid and line spacing that shrinks towards the vanishing line. It's going to layer a simple noise ridge for mountains and animates with a tiny camera drift. The result is a bold look with tiny code. Then we have stable fluids. We asked for a fluid sim with dyes and sliders. Under the hood, GTP5 sets up velocity plus dye fills and ran stable advection and diffusion steps in a ping-pong pair and clap DT to avoid blowups. Then why this matters is it grabs a proven method and keeps it interactive. So for the Canvas Physics Mini, we wanted little shapes that bounce and stack. Under the hood, it went with cheap circle box checks, gentle damping, and fixed time steps so collisions stay consistent. No physics engine, still satisfying. So the point is to pick lightweight rules and keep frames happy. And so for the 2D in-body canvas, we asked for particles with gravity. Under the hood, we used simple Newton pools with softening to prevent blowups, and a bucket grid so it's not doing n squared checks every frame. So the lesson is a small op choice changes everything. Okay, then we get to the big cats, collapsible tree, masonry, and tree. We asked for a simple taxonomy view. Under the hood, it built a tiny tree model, toggle branches, and used a clean tooltip. Not a research paper, just a clean structure on click. So the takeaway is GTP5 is good at organizing info very fast. So, and for the outro here, we have the kinetic outro and just some credits. We asked for a kinetic credit scene to end on. Under the hood, it sequenced text with a single timeline, eased motion, and respected reduced motion if your operating system asked for it. So, wrap is a short prompt in, polished outro out, and just one little file. So, one of my reflections here, or many reflections I'd say, is what surprised us most wasn't speed, it was probably the planning, because it wasn't exactly fast to do any of this. But GTP5 kept picking data shapes that matched the idea, like trails, grids, graphs, and paths. It would choose safe loops, so fixed DT, buffers, and budgets, so the frames didn't tank too much. Wiring UI and guardrails without hand-holding was pretty good. The sliders, outputs, just some error overlays, software in it. Favoring simple math that scales, buckets over brute force, typed arrays over objects, draw order over effects. So it's not really magic, it's a stack of small, sane decisions made fast. So less time fighting the boilerplate and more time tweaking the idea together. So if this is what we get from tiny prompts today, imagine in a month or two, imagine down the road, imagine in a year. So we're gonna go ahead and drop all these prompts we used somewhere, maybe on the school. Join my school if you want to see it. It has no libraries, just one file projects, so you can build with us. Hit like, sub if you're into this kind of hands-on AI building, and tell us which app you want us to push further next. So short prompt in, working app out. That's pretty much ChatGPT 5. Thanks for watching.